Quantum computing is going mainstream. Major tech companies headed by IBM, Google, Microsoft and Nokia Bell Labs, as well as other startups like D-Wave Systems, all have quantum computer roadmaps with varying goals, timelines and development. Hundreds of millions of dollars are invested in their development. Why is there such a fuss around them? Are the quantum computers different from classical PCs? Whether quantum computers will be able to fulfill the optimistic predictions of futurists, or vice versa, will bring techno-apocalypse? Let's see what's the essence of the battles of computers. Before understanding how the quantum computer works, you need to understand the basics of quantum mechanics. You cannot imagine how impoverished our world would be without quantum mechanics.
Run.
Without quantum mechanics and without a knowledge of how to use quantum mechanics, there will be no mobile phones, no CD players, no computers. All of these rely on the properties of quantum mechanics.
However, quantum mechanics is not an easy thing. No wonder that the first rule of quantum mechanics: do not tell anyone about quantum mechanics. Feynman even joked that,
on the other hand, I think I can safely say that nobody understands quantum mechanics.
in the early 20th century, scientists discovered that the atom has a nucleus and an electron. Max Planck suggested his famous formula, later called Planck's constant. It defines the boundary between the microscopic world, where are the laws of Newtonian mechanics, and the microcosm, where the laws of quantum mechanics are applied. Well, after came the golden age of physics. Schrödinger, Born, Heisenberg, not these, but these. And others laid the foundation of new science. They tried to determine the properties of an electron, including its behavior under different conditions. It turned out that an electron is very tricky, and description of its behavior requires a special science, which they call quantum mechanics. It describes all of the properties and behavior of atoms, ions, molecules, and generally everything that happens in the microcosm. And why quantum? Because quantum in German means the tiniest indivisible piece of energy.
Quantum carburetor? Jesus, Morty, you can't just add a sci-fi word to a car word and hope it means something.
So, we found out the origins of this science. Now it's time to proceed to the actual invention of quantum computers. Briefly, milestones of quantum computer development are following. 1981. A pure simple model of quantum computer was proposed by Richard Feynman in his famous lecture Simulation Physics on Computers at the first conference of computational physics. Similar ideas were expressed by Paul Benioff and mathematician Yuri Manin. 1982 introduced the notion of quantum Turing machine. David Deutsch showed that the processing powers of computers that use manipulation with atoms and molecules may exceed the capabilities of classical computers. 1994, Peter Shor discovered an important algorithm that allows quantum computer to rapidly perform a factorization of large integers. Year 2000 was demonstrated the first working 5-qubit computer in the Technical University of Munich. 2007, Canadian company D-Wave demonstrated the first 60-qubit quantum computer. In fact, use of quantum technology can be divided into two stages, the so-called revolutions. The first quantum revolution that took place in the middle of last century led to the creation of nuclear weapons, nuclear energy, and semiconductor electronics.
The first quantum revolution. It allowed us to understand why the stars shine. It allowed us to sequence DNA and usher in the age of molecular biology. It ushered in the entire semiconductor revolution with the invention of transistors and semiconductors, lasers, nanotechnology, nuclear energy. All of that was enabled by this original understanding.
But a successful quantum teleportation and the invention of a quantum computer are referred to the period of the second quantum revolution that's happening here and now. Since Moore's law is gradually becoming a reality, at last the first workable quantum computers appeared. Engineers are beginning to investigate new types of processors that use atoms as transistors and leverage the power of quantum physics to process large amounts of data that not even classical silicon-based supercomputers can handle.
So we exploit that fact of quantum mechanics, that particles can do many things at the same time, to do many computations at the same time. And that's what would make a quantum computer so powerful.
Such a computer can instantly make calculations and work with a large amount of data, hundreds of millions faster than a normal PC. The reason why they are so powerful lies in the principle of their work. If conventional machines use bits, zeros and ones, then in quantum analogs they are replaced by quantum bits, qubits. In fact, this is the smallest element for storing information in a quantum computer.
Quantum computers compute on individual atoms. And instead of zeros and ones, which are called bits, we have quantum bits or qubits. That is sometimes 1, sometimes 0, sometimes any number in between 0 and 1.
So, the source of the power of quantum computers is that these qubits can simultaneously be in many states, and not in just one like ordinary bits. Quantum bits can immediately perform a huge number of operations. This property will help you to make more accurate calculations, make medical and chemical discoveries many times faster and more efficiently than on classic computers. But back to our qubits. By the way, they can be different. There is a theoretical concept of a qubit as a unit of quantum information, and there is a physical embodiment of qubits, photons, ions, spins of nuclei and electrons.
There is no way you can write in your desktop computer a code where 2 bits have no value but have the opposite value. But you can do so in a quantum computer.
In an ordinary computer, it is impossible to use the properties of quantum objects, and this is their main difference. So, the qubits act on 2 key principles of quantum physics: superposition and entanglement. Superpositions mean that each qubit can simultaneously represent both 1 and 0, well, as with the Schrödinger cat. And entanglement means that the observation of one of the 2 particles leads to the fact that it behaves in a random way, but precisely indicates to the observer how the other particle will act if similar observations are made with it.
Gaining access to these entangled quantum states is the key to exploiting the exponentially large computational power of quantum systems.
Well, at first and at second sight, it's difficult to understand all this stuff, but do not worry, because only 1 person out of 10,000 understands quantum mechanics. Very soon, on the second part of our video, you will learn how to program a quantum computer and where they are used.
Like business requirements from organizations, and we analyze those requirements, and then we build software to fit those requirements.
He is a virgin.
Subscribe to our channel not to miss the next video. Hit the like button and share this video with friends who want to understand what quantum computers are.